Hello everyone, welcome to the video on fundamental steps in digital image processing. This image gives you the fundamental steps in digital image processing. Yes, see here, these are all the steps. See, this is image acquisition, image enhancement, image restoration, color image processing, wavelets and other image transforms, compression and watermarking, morphological processing, image segmentation, representation and description, and object recognition. See, these are all various steps in digital image processing. Whenever you want to do some processing for the image that becomes the problem domain, then these are all the steps that you have to perform to get your required processing. This diagram does not imply that every image problem, every processing needs all these steps. Depending on the problem domain, depending on the requirement, yes, we have to go for different steps. Not all the steps are required for every processing. Sometimes image enhancement is needed, sometimes compression is needed, and sometimes image segmentation is needed. In that way, depending on our problem, you have to choose these steps. Okay, and see here, yes, outputs of these processes generally are images. See here, I've marked from this image acquisition to morphological processing. Yes, for all these steps, the outputs are images. Inputs are images and outputs are images. And for these four, outputs of these processes generally are image attributes. Means the output is not a complete image. It may be a partitioned image. The outputs may be features. The outputs may be some values like that. It's only the morphological processing. We are getting two things. Sometimes the output from the morphological processing step may be image, and sometimes it may be image attributes. I'll see one by one about these steps. The first one is image acquisition. Image acquisition can be defined as the act of procuring an image from sources. Means getting an image. Acquiring an image is called image acquisition. This involves capturing an image using a digital camera or scanner or importing an existing image into a computer. Yes, to get image or to have image, what we have to do? Simply the thing is you have to capture the image using camera. That's all. That is the simple one. See this, this is a camera, old camera, and this is a digital camera, and this is phone by which we can take the images. Or image acquisition may have importing an existing image into a computer. Okay. Then is image enhancement. What is image enhancement? Manipulating an image so that it can be more suitable for specific application. Enhancing means improving the picture quality. How to improve? By increasing the contrast and reducing the noise and removing artifacts. See the example. See the original image? It is not good. It consists of noise. It consists of some contrast issue. It has many artifacts. But if you see the enhanced image, see, you can observe enhanced image. Yes, it's a good image. From that image, you can get more details and it's more suitable for specific applications. The other one is image restoration. Image restoration, I can say same as that of image enhancement, means the output is same as that of image enhancement. See, this is image enhancement and this is image restoration. See the example. This is the original image and this is the restored image. What is the difference between image restoration and image enhancement? See, image restoration is an objective phenomena. Objective phenomena means the output of that restoration process is evaluated using mathematical formulas, some mathematical approaches, using some performance parameters. But in the case of enhancement, it is completely subjective. Means the output of the image enhancement is evaluated just by human eyes. Human can identify whether the enhanced image is good, is best, better, poor, like that. That's the difference between image restoration and image enhancement. Okay, the next is color image processing. Once again, I'll show you the total diagram of fundamental steps in digital image processing. See this. We completed acquisition, enhancement and restoration. Now what is color image processing? Yeah. Color image processing is an area that has been gaining an importance because of the significant increase in the use of digital images over the internet. Yes, color is used as a descriptor for the image. Color is used to extract the image. As the technology is improving a lot, color image processing has gained more importance. So in the color image processing, every pixel of the image is having 3 values. I told you at the beginning class, those are RGB. That is the reason color image is a 24-bit image. You can identify the features of the image if it is a color image. See this image. This consists of 3 parts, red, green and blue. You can describe about the image if it is a color image. We can't describe about an image if the image is a gray level image. Because human eye can't identify more number of gray levels. But the same human eye can identify more number of colors. That is the main reason of going for color image processing. Next is wavelets and other image transforms. Wavelets are used to represent the image in various degrees of resolution. And it is used for image data compression. And with the wavelets, you can represent the image in the form of pyramid. See this? This is the pyramidal representation of an image. See the below one? The below one is having high resolution. And when you're moving up, the resolution becomes less. See this example. The same image is represented in the form of different resolutions. This can be done only with the help of wavelets. We can go for compression also with the wavelets. The other image transforms are used to represent the image in frequency domain. See here, if you represent any signal in frequency domain, we know that we'll get many frequency components and we can eliminate which are unwanted and we can enhance which are wanted. Same way, when you are able to describe an image in the form of frequency components, okay, you can enhance the required image components and you can eliminate the unwanted image components. The next one is compression and watermarking. You know the compression. Compression is simply reducing the size. Yes, we have many compression coding techniques. In future, I'll see various compression coding techniques. Without knowing about the compression in detail, we use it to save the image like .jpg, .png, .tiff, .bmp. What we are doing by saving the image like this? We are nothing but doing compression. Automatically, the image becomes compressed when you save the image like .jpg, .png, .tiff and .bmp. These are all image file formats. See the example. So this is of a 12 MB size. After the compression, say this is 10 KB photo. Is there any big difference? So these two appear same. Means compression won't change the image. Or if any changes are there, the changes can be negligible. Because in the compression, there are two types of compressions, lossy compression and lossless compression. In the lossless, you won't get any disturbance for the image, but in the lossy, you'll get some loss, but that can be negligible. The next one is digital watermarking. Is the process of embedding a digital code into your digital content like image, audio or video. Say this image, the first one is normal image and this is visual watermarking image. What's the purpose of having watermarking? It's nothing but it is a type of having patent. Suppose if I represent Adhyayana on any of my video, then what I'm saying to the viewers or what I'm saying to the people, I'm saying it is my own video. You can't copy like that. In the same way, if a watermark is there in any image, it means that we can't copy it because it is some other's image. It is the property of some others. Right is only for the creator. We can't copy. Next is morphological processing. Morphological processing deals with the tools for extracting image components that are useful in the representation and description of the shape. Morphological processing is used to extract image components. See this binary image. It consists of many small and big squares. Here I want to explain about morphological processing. This is a simple example. See this, the second one, this is eroded image. Eroded. Erosion. Erosion means what is erosion? Yes, shrinking, nothing but shrinking. So if you observe, see this is the big square and this is the big square and this is another big square. Only 3 big squares are there. The eroded image consists of a small dots in these 3 big square regions. And if you dilate the same eroded image, see this, you're getting the same sized squares in the dilated image. Next one is image segmentation. Segmentation means partitioning an image. Partitioning an image into its constituent parts or objects. The more accurate the segmentation, the more likely recognition is to succeed. See here I've given one example. This is the original image. Okay. It consists of flower and this green portion and this black portion. So totally 3 different colors are there. Say the segmented image. Yes, these 3 regions are partitioned. So see here we are seeing only 3 parts. So that we can recognize the part easily. This blue part is the flower part. This light blue part is the leaf part. And this yellow part is the tree part. Okay, so that we can recognize the image more accurately. This is called segmentation. So segmentation is just partitioning an image to identify or to recognize it. Next one is representation and description. I'll show you the diagram again. See this. Yes, we are here. Representation and description. Yes. What is representation? Make a decision whether the data should be represented as a boundary or as a complete region. It is almost always follows the output of a segmentation stage. I'll tell you by taking this example. Say this. Yes, after segmentation we got 3 regions. To represent the image, it is better to go for region wise. It is one region, it is another region, it is another region. So this is called region representation. Suppose if it is boundary representation, we must focus on external shape characteristics such as corners and inflections. If it is region representation, focus on internal properties such as texture or skeleton shape. See this, I told you, this is the internal property. We focused on internal property. We focused on regions. It comes under region representation. So what we can do with the representation? we can transform raw data into the form suitable for subsequent process. Then what is description? It deals with extracting attributes that results in some quantitative information of interest or are basic for differentiating one class of objects from another. What is description? It deals with extracting attributes so that we can describe the image, so that we can differentiate one image from another. Next is object recognition. Say, this is image segmentation. Here we divided the image into different parts. By using this representation and description, we represented this image as regions. This is one region, this is one region, and this is one region. Now, after representing it as regions, then we have to identify. Then we have to recognize the object. Yes, this is the object recognition. Recognition is the process that assigns a label to an object based on the information provided by its description. Okay? See this. Suppose if this total is your image. Yes, then go for segmentation. So after the segmentation, you'll get different parts. This notebook is one part, and this glasses becomes one part, laptop becomes another part, iPhone becomes another part, coffee becomes another part. After getting these 5 parts, by using the representation and description concept, yes, we can identify each region by going for either boundary or region representation. After representing, we can label it. That is called object recognition. Labeling means giving name. These objects are labeled based on the information provided by description. Yes, all these steps are connected to the knowledge base. What's the meaning of the knowledge base? Knowledge about a problem domain is coded into an image processing system in the form of knowledge database. With the knowledge database, we can apply different image processing steps that are required to solve all problem. Sometimes the knowledge may be simple as detailing regions of an image where the information of interest is known to be located, simply identifying the regions. Sometimes it may be quite complex, like identifying the major possible defects in a materials inspection problem, or an image database containing high resolution satellite images of a region, like that. Suppose if it is example, and a simply enhancement, the knowledge database is very simple. But if it is like object recognition level, then obviously your knowledge base is quite complex. Okay, so that problem is coded in image processing system in the form of knowledge database. That's all is in knowledge database only. In addition to guiding the operation of each processing module, so knowledge database guides all these processing steps. If you see, all these steps are connected to the knowledge database. See this is all connected to the knowledge database. How these steps are to be executed? How to do image enhancement? How to restore the image? How to segment the image? All these things are in knowledge database. The process is included in knowledge database. The knowledge database not only guides the individual processing techniques, it also controls the interaction between modules. Okay? So whenever you identify a problem, then that problem is coded into knowledge database. Then knowledge database guides the steps, whether that problem needs the enhancement or compression or segmentation, morphological processing, some representation or recognition, like that. It identifies the problem and it guides the module. If at all any intercommunication is needed between the modules, that is also instructed by the knowledge database. Okay. So this is about your fundamental steps in digital image processing. Okay. This is all very short description. Every step is a chapter. Okay. And future classes will deal every step in detail. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.